Okay, so first part of chemistry I'll look at is properties of matter. Just in case you've done the reading, you'll see what we're talking about. So the first question is, why are windows made of glass? And we'll learn how we can classify matter based on this idea. So when you observe matter, here's what you look at. Colors, shiny or dull. When we look at a liquid, is it viscous or not? Does it flow quickly or slowly? What about gases? Is it odorless or does it have a smell? Those are things that we can describe when we look at properties. Properties you describe matter can be one of two things, extensive or intensive properties. Extensive properties deal with anything that has mass or takes up space. Or that's what mass is. So when we talk about extensive properties, mass is a measure of how much matter it has. The mass of a basketball is greater than that of a golf ball. And that is an extensive property. Extensive properties, like volume and mass, tell us things about the property. So it depends on the amount of matter. So if you look back, volume, the basketball takes up more space than the golf ball. The basketball has more mass than the golf ball. They are extensive properties because it's based on how much matter is in the sample. Intensive properties, now let's talk about basketball again. Basketball could be made of a lot of different materials. It could be leather, it could be rubber, it could be a composite, one that you can use for outside. But each of these materials has different properties when you talk about basketballs. Leather balls are suitable for indoor play but not outdoor play. And there's reasons for that. So now, intensive properties are those that depend on the type of matter. So what's it made out of? So is it made out of leather? Is it rubber? Is it synthetic? Those tell us what intensive properties are. So extensive is based on amount. Intensive is based on the type of matter. Now, identifying a substance, how can we use to identify substances? Soda can's mainly aluminum. This water can is mainly copper. Those are things that we can use to identify the chemical makeup. Matter that has uniform and definite composition is called a substance. Aluminum and copper are substances. Another term that could be used is pure substances. Now, they also have some properties in common, but they have some that are also different. So let's talk about them. Aluminum, highly reflective, often used in silver paint. That's a way to talk about aluminum. Copper can scratch the surface of aluminum, so it's harder than aluminum. Copper is a very good conductor of heat or electric current. Copper wire, really good for stereos. They are both malleable, which means we can shape it. These are all different ways to describe matter. Reflective, hard, conductors, malleable. Those are things that we can use to describe substances. We call these descriptions physical properties. So it's a condition of a substance that can be observed without changing what it is. We can look at copper and use copper in ways to know these things about copper. Here are some physical properties of different substances, again taken from your text. Neon's a gas, it's colorless, melting point, boiling point. These are things that are physical properties. So boiling point, melting point, color, state. Those are things that are physical properties. They can also help us identify substances. So let's say we have a colorless substance that was found to boil at 100 degrees Celsius, melt at 0 degrees Celsius. When I look at that list from before, 100 and 0 right here, more than likely it'd be water, or at least I can make that guess. A colorless substance that boiled at 78 degrees Celsius and melted at negative 117. 78, 117, negative 117, probably ethanol. So we can use physical properties to identify substances. And so why is glass good for the windows? Because it's transparent. Transparency, another physical property. Copper is not transparent, so obviously we don't want to have windows made out of glass or copper. So now, you want to compile a list of property sets, but you don't have a way to measure mass or volume. What kinds of properties can you determine without knowing the amount of matter in the sample? So without knowing the amount, right? All right, we're looking at intensive properties here. And that will tell us what we need to know. So states of matter, very quickly, this is something you probably should have learned in ICP, but we'll go over it. Water is the most common substance and exists in 3 different physical states. So the 3 states of matter are solid. In a solid form, okay, it has what we call a definite shape and volume. It will keep its shape and volume no matter where we put it. We can put it in a box and it will keep the same shape and volume. The particles packed together tightly in a nice orderly arrangement, and we'll get more in detail what that is, but they do vibrate slightly. But the shape doesn't depend on the container, so shape and volume, not important. So now, things about solids, incompressible. That means we can't press them any further closer together than what they are. And because of this ability to the particles, they will expand slightly when heated, but not a lot. They will still stay that way unless we get them to change state. And this next state after solid would be liquid. So if we heat a solid enough, it will become a liquid. So the particles in a liquid still close together, but what they do is they flow. They kind of move around each other. And so when we talk about liquids, they take the shape of the container they're in. You get milk in a jug, you pour it in a glass, it always takes the shape of the container it's in. But the volume does not change. So that's an important fact. Shape stays the same, or volume stays the same, but it takes the shape of its container. That's what liquids do. So indefinite shape flows, but has a fixed volume. So takes the shape of its container because it flows, and the volume is constant. Liquids, incompressible. You cannot push liquids any closer apart than they want to be. But when you heat them, they again also will expand, just like solids. Gases take the shape of their container, but they also will fill the container, so they also will take the volume of their container. So gases take the shape of their container and the volume of their container. And that's what gases will do. They will fill the entire room. That's good for us because we wouldn't be able to breathe otherwise. Gas are much farther apart than the particles in the liquid because they have so much energy. They are really bouncing around a lot. The thing about gases, other than liquids and solids, is that we can compress gases. We can take these particles and push them closer together. We can put them in a smaller container if need be. Vapor and gas, two terms that sometimes are used interchangeably, but there is a difference. Just understand, gases are for substances that are gases like oxygen at room temperature. Vapor is what happens when we get gas, when a liquid is heated. So when we talk about water being a gas, water vapor. When you boil water for mac and cheese, you make water vapor. A substance is in a state in which it takes the shape of its container. What state or states could it be in? Takes the shape of its container. What do you think the answer is? It could either be a liquid or a gas. We need more information, but we know if it takes the shape of its container, it's a liquid or a gas. Solids keep their shape. So physical changes. This is gallium metal. Gallium, as you see, is like a liquid metal. Probably not wise to touch it with your hand, but the heat from a person's hand can melt it, so it has a very low melting point, 30 degrees Celsius. The shape changes as the liquid begins to flow, but the sample does not change. It's still gallium. Melting is a physical change. A physical change is when some properties change, but the composition doesn't change. What that means is it's still gallium. It's still whatever it is. When we melt ice, it's still water when it becomes liquid. So boil, freeze, melt, those are physical changes. Break, split, grind, cut, and crush. These also are physical changes. Anything that doesn't change what it is. It may change the appearance, but it doesn't change chemically what it is. Physical changes can be reversible or irreversible. Melting can be reversed. All we got to do is cool it back, and it will become a solid again like gallium will, like ice does. Cutting hair, filing nails, cracking an egg. These change the physical appearance. Don't change what an egg is. Don't change your nails. Don't change what your hair is. But they're irreversible. We can't reattach the hair or reattach the nails or uncrack an egg. Water boils and becomes water vapor. Is this a reversible or irreversible physical change? Obviously, we talked about that. It is reversible because it involves a change from one state to another. We know we can take water vapor and cool it back down to a liquid, condensation. Okay, so glossary of terms, things that you should know, and I'm going to go slowly through this. Mass, volume, extensive, and intensive properties. We define those. What's a substance? Physical property, solid and liquid. Again, we define those. You can pause at any time and read these. A gas and a vapor, same but different. Vapor's what happens when a liquid makes the gas at a different temperature than room temperature. Gas is something that's a gas at room temperature. A physical change is when properties change, but the composition stays the same.